It's right at noon, so let's go ahead and get started because we have a very action-packed webinar for you today. So, hi everyone, thanks for joining us. My name is Joy Payton and I use she, her pronouns. I'm a member of the data education team that forms part of the ARCUS initiative of the CHOP Research Institute. And today's talk is the fourth topic in our 5-topic series on SQL or SQL. At the end of today's talk, you will get a link to sign up for the final topic, SQL Joins, if you are so inclined. So if you want to follow along in today's presentation, my colleague Rose has shared in chat the link to the slide deck that I am sharing right now. So that you can follow along. And I do recommend that you go ahead and click that link because today's webinar is hands-on. So you will want to have access to this slide deck so that you can do all of the activities that we're going to be working on together. Today's webinar is going to be recorded. So please leave your cameras and mics turned off until the question time at the end. And that's when I will turn the recording off so that we can all feel comfortable asking questions without being recorded. If you do have questions that come up during the talk, feel free to put them in chat. I do have chat visible, so I will be able to see those and respond. So today we're going to be doing some more advanced SQL queries on single tables, and we're going to be writing some real SQL code. And if that sounds daunting, do not worry. We're going to have lots of scaffolding for you today, and we are going to work through things together. So with that, let's go ahead and get started. So with the most recent webinar in this series, my colleague Rose Hartman, who's here with me today, showed how to compose some simple queries using words like select, where, from, distinct, as, and order by. And that really sets us up well for today's learning objectives. So today, after a quick review of the commands that we went over last time, we're going to learn how to write more complicated queries. So today we're going to use case, like, and group by. And along the way, we're going to learn about some aggregate functions, as well as practice and refresh the skills that you already know. So this is our thank you slide. So material for this talk is closely based on the Dart module SQL Intermediate Level. That was written by Peter Camacho and by me. And it does feel a little weird to acknowledge myself. I'll admit that. But I do want to promote a culture of acknowledging the sources that we use here. So our webinar today will not cover all the topics in the module that Pete and I wrote. It's just simply too long. And in fact, we may not reach the end of all the materials today, depending on, where we stop and what questions we have along the way. So I really do suggest that you check out the module that Pete and I wrote after our webinar today. And Rose has been kind enough to drop that link into chat. So take a look at that. It really has a lot of material that we will not be able to get in today, just out of question of available time. We're firm believers in my team that the best way to learn is to practice hands-on. So as I mentioned before, we will have opportunities to practice writing our own SQL code today using a fake patient database. And there'll also be some poll questions to help solidify your understanding as we go. I'm going to make this a little, let me make this a little bit bigger. There we go. Thank you so much, Rose, for putting the link to the slides again. So let's do a little bit of a refresher of what we've gone over so far. SQL, or SQL, and you can say it either way, stands for Structured Query Language. And it's a programming language that is used to interact with relational databases. And relational databases consist of many different data tables. Today, we're going to be working with data just from one table at a time, even though the 3 tables that we're going to work with today are stored in a single database. To learn more about combining data from more than one table, you will definitely want to catch our final presentation in the series, which is called SQL Joins. Now, SQL is great at selecting just the data you want from rectangular data that is stored in tables with rows and columns. We also sometimes call columns fields. However, SQL is not necessarily great for fine-tuned statistical, linguistic, or data visualization purposes. SQL is therefore a tool that is often partnered with other languages like R, Python, or the Stata language, which are better suited for work like statistical analysis. We will, however, see some of the ways that SQL can generate some simple summary statistics today. So let's talk about the dialects of SQL. SQL has various flavors or dialects that have small differences in their implementation. And there will be a couple of moments where I might mention that the dialect makes a difference. Because different dialects of SQL can have different outputs, knowing the specific dialect or flavor of SQL that you're working with can be useful when you're first getting started. And in the hands-on portion of this webinar, we're going to be using what is called AlaSQL. This is a really lightweight form of SQL that runs in your web browser. We pre-populated some tables for you to experiment within. And so we're going to use some tables that are filled with fabricated data that are meant to look a little bit like an electronic health record. Rest assured, these data tables are completely fabricated and made up, although the data might look realistic. So that's what we'll be working with today. Before we learn the new commands today, let's just go back over what we've learned earlier in the series. The basic structure of a SQL query is select, followed by some field or column names, then from, followed by one or more table names, and then possibly where, followed by a filtering condition. And to start exploring the patients table from the AlaSQL database, we can first take a look at all of the fields in the table, using the asterisk here as a wildcard to select all the fields. And I'll click the Run button here to run the code. Hit that play button. And when you run your query, the results of the query are placed in this collapsible area below here. And if there's any error message, that will appear in this black bar section between the code block and the results of the query. All right, so that's using the asterisk, but really, once you know what the columns are, you really should only select the columns, or you might say the fields, that you actually need. So we recommend using dot notation, using the table name, dot the field name, and a comma first style, as you see here, to list the specific fields that you want to see. So let's run this and look at this outcome. All right. And if we want to filter our outcome, our output, we can use the where clause. The where clause is the section of your query used to specify any filtering logic that should be applied to your query before returning any output. It's optional, but we use it a lot. So as an example, this is how you could filter the output to include only the records for a specific county. In our case, specifically, Suffolk County. And we can see that that really cuts our output down to just what we're interested in. We'll also take a look at distinct and order by later on in our webinar today. All right, so we've reviewed some of the basic SQL that we've covered in earlier sessions. So let's learn some new SQL keywords and explore our database a little further. Our example database today has 3 tables. It has patients, allergies, and observations. So let's look at the observations of peanut immunoglobulin E antibody in serum in the AliceSQL.observations table. Let's run this code. And if I take a closer look at the observation value field, those numbers, I'm not a clinician. I'm certainly not an immunologist or an allergist. So these numbers might be meaningful to you if you're a clinician who specializes in this. They're less meaningful to me. And so it would be helpful for me if I could classify these data into something that's a little bit more meaningful. And this happens a lot, where we want to define our own custom categories or groupings. So, for example, I might want to have lipid levels classified as normal, borderline, abnormal. And this is how we're going to use the case statement today. So the case statement is used to produce conditional row-level output. It's like an if statement, but with multiple possibilities or cases that are considered. So let's take a look at a generic example, and then we'll put it into practice. So we're going to look at the components of the case statement, and we're going to start in the middle of the case statement and work our way out. So conditional statements in SQL use this when-then form. So when the conditional statement is true, then the designated output will be returned to you. And you can have as many conditional statements as you want. Be aware, however, that for each row that you're evaluating, SQL will only return one output corresponding to the first time a condition is found to be true. So let's give you an example here. Let's consider what these statements would do in a row where patients.age, by the way, that's not an actual field in the patients table, but let's say it is. And let's say that age in this particular row is 10. So if patient's age is 10, well, then this evaluates as false. 10 is not less than 1. So this does not trigger. So this when then does not trigger. Let's look at the next possibility. When patient's age is less than or equal to 12. Is 10 less than or equal to 12? Yes, it is. So this triggers, and so this is the first when then to be triggered. That means we are done checking. We are not going to keep going down the list. So age 10 is going to be classified as child. Even though it is also true that 10 is less than or equal to 17, that is also true, but we have stopped checking, right? So we have stopped checking at 12. So the row that has an age of 10 is going to be classified as child. Else comes at the end of all the when-then statements, and it tells SQL what to return if none of the cases, if none of the when-then statements evaluate to true. And if you leave out the else clause, SQL will impose a condition of else null by default. We strongly encourage you to always include an else clause, even if you like the default value of null, just to make your code more explicit, because you can always just explicitly say else null if that's what you like. Finally, you do need to open the statement with case and close it with end. Now, the indentation before each of the when statements and the else statements are for us as human readers of this code. SQL does not need these lines to be indented, but it makes it a lot clearer to us where this block of code starts and ends. So we've started with a lot of theory and sort of walking through this example because case statements can be complicated. So let's go back to the observations table that we were looking at and actually put this into practice. All right, so here's an example. A case statement goes between the select statement and the from statement. We might know that if the observed value of IgE antibody is greater than or equal to 17.5, that is a strongly positive result. And we may also have known cutoff values that correspond to positive, equivocal, borderline, and negative results. And this might be helpful in writing reports to help families understand what these values mean. So let's run this code. This code gives us everything from the observations table. You can see it says observations.star, so it gives us everything from the observations table. And then it gives us this sort of category here. Actually, let me just remove this. This doesn't, I've got some, I've got a little bit of, I've got some caching issues. Hang on just a second. I'm going to change my browser real quick to another browser window because I'm having some caching issues. I apologize. And I'm going to stop sharing and share from this that doesn't have the answers already in there. There we go. All right. Perfect. All right. So now that I've got this in my incognito window, I think this will be a little bit better for us. Let's run this code. We're getting everything from the observations table, and we're getting some sort of classification here, right? We're going to get one of these words back or null. It's one of these phrases back or the word null. So let's hit run on this and see what this looks like. All right. When we run this code, we get a new column, and it does have these phrases in it: strongly positive, and positive. The data here looks great, right? The data looks good, but this column name is very ugly, right? This column name has that entire case statement. So we can make this column name much nicer by using an alias. So I'm going to scroll up here, and immediately after the word end, I'm going to put as interpretation and add an alias there and run that. And now we have the same data that we had before, but we have a much better column name, interpretation, instead of that very long, awkward column name. And let's just look at an abstraction of what we just did. It's usually a good idea to follow a closing end here with an alias giving a useful column name. So I want to pause here, especially because I had to change the browser window. Apologies for that caching issue. To answer any questions, because we're about to jump into giving you a chance to practice on your own. So any questions that people want to ask before we jump into your turn? All right. I don't see any questions. If you do have questions, feel free to drop them into chat. Rose is going to, thank you, is going to drop the link into chat. So if you're not already following along in the slides, you now have a link directly to this example. So you can be taken directly to this page. So let's say you are studying attitudes about smoking, and you're going to issue a survey in phases. So phase 1 is going to go out to residents of Plymouth County. Phase 2 is going to go out to residents of Essex County, and phase 3 will go out to Barnstable County. So I'd like for you to finish the query that's shown so that you get the patient name, first and last, the county, and a new column called phase. I'm going to give you a few minutes to try this on your own, and don't forget you can use the forward and back pagination to look back at what we covered earlier today in case you want to copy and paste or you want to look back and see what we've done before. So there's a comment in chat that you can see there. So when you have had a chance to work on this and you're ready to move on, just give that comment a thumbs up, and that's how I'll know that we're ready to progress. Excellent. I'm loving all the participation. Thank you for that feedback. Seems like folks are getting a chance to participate. All right. So I'm going to go ahead and keep moving because we've got a lot of material today. So the first thing that we want to do is complete the when-then statements. And so I'm going to add patient county equals to each of these when-then statements. And so I'm going to do some copy paste here. And I believe phase 2 is Essex County. And I want to make sure that I got my capitalization and spacing correct. And then I believe this is Barnstable County. And this white space that I'm erasing doesn't matter, but I like to neaten it up. And I'm almost done because this will assign the phases correctly, but I do want to give this column a useful name. So after the end of my end statement, I'm going to say as phase. And let's see if I got that right or if I committed any typing errors. Yep, I think that looks correct. Great, so hopefully that looks like what you got. Excellent. All right. Let's talk about this keyword like. So far, we have run queries in SQL that assume that we know a lot about our database. And sometimes that's true, but sometimes we don't know exactly what's in our data or how people chart or how people describe things. And we can use select distinct to learn more about our database, to sort of understand a little bit more about our database and move forward from there. So let's take a look and see what kind of allergies are in our database. You can see here I'm using select distinct allergies description. So let's take a look and see what we have here. All right, we've got some animals, we've got some food, we've got some pollen, all right, we've got some environmental allergies here. And let's say that you are interested in all types of pollen allergies, but you're not interested particularly in other allergies. Now, if you wanted to look up just the data related to pollen allergies, you could get that information using a where statement. So you could make a where statement like this. We talked last time about using or, right? You could list out every possibility that you know of that mentions pollen with an or between them. And in the very small table that we're working with here, this method works fine. But if we were looking at real patient data, there might be hundreds of types of pollen allergies. And different people chart different ways and describe things in different ways, right? So the same allergy might show up typed in as allergy to grass pollen by one person and grass pollen allergy with slightly different wording and different capitalization because different people write it out differently. Or maybe a new patient comes in who has a new different pollen allergy. They're the first person to be entered into the database with that particular pollen allergy. It's something we haven't seen before. So in that case, if you were relying on this query to capture all the pollen allergies, you would need to update that query, or you would run the risk of missing someone who has a novel allergy. So you can imagine that this level of specificity is error prone. So how can we get all of the pollen allergies without having to specify all of the possibilities? And this is where the like operator can help us out. Like operators allow you to compare text data to a pattern rather than checking to see if two strings of characters match perfectly using the equal sign. And this action is known as pattern matching, and it can let you filter on row values that are similar but are not exact matches. The like operator uses two distinct wildcard characters that let you create patterns where some of the characters are unknown. So the percent character or symbol is the wildcard for 0 or more characters. And the underscore is the wildcard for exactly 1 character. And these wildcards let us build patterns to compare with a string of text data. So let's take a closer look at some examples. We'll use the percent wildcard. So putting a percent symbol at the beginning means that anything can come before the characters in the description, let's say, but the description has to end with pollen for this to be a match, right? So percent pollen matches the string allergy to tree pollen, right? Because there's some characters and the final 1, 2, 3, 4, 5, 6 characters are pollen. All right, so that is a match. If instead the percent symbol is after the string pollen, a phrase would have to start with the letters pollen to be a match. And importantly, capitalization does matter to the like operator. So if the P were capitalized, but we gave the string to match being lowercase pollen percent, that would not be a match. So in this example, lowercase pollen percent matches lowercase pollen allergy dash trees, but it would not match uppercase pollen allergy dash trees. And to match both of these possibilities, pollen at the beginning, pollen at the end, we can put percent symbols before and after. So that way we could have tree, pollen, allergy. There's something before pollen, there's something after pollen, and pollen is it could be in the middle, right? So that matches percent pollen percent will match allergy to tree pollen. It will match pollen allergy trees, and it will also match tree pollen allergy. All right. In the same way, by the way, that we need quotes around the data that we want to match exactly when we were comparing strings using equal sign, we also want to make sure that we're putting what we're comparing in quotes here. So you can see here. I want to make sure that I'm putting things in quotes. All right. Now, before we do our example, oh, yep, in there. There's our quotes there. Exactly. Now, before we do our example, I do want to do a quick poll just to check our understanding of like. So there's a poll available for you. Please go ahead and just tell me what you think. Just to sort of take the temperature here. All right, great. Seeing lots of responses there. So you're answering correctly that like can help us find patterns that are relevant to us, such as pollen allergies that will emerge in the future, or pollen allergies that people might list in different ways. And it certainly can help shorten that query. And you are right, capitalization, that was a trick to see if you were paying attention. You were. Like does not automatically handle capitalization, and I will show you how to handle that now. But let's apply this structure, this wildcard structure in like, to find the pollen allergies from our AliceSQL.allergies table. I'm going to run this query, and let's look. Let's look at all these pollen allergies. There they are. And let's imagine, this is not the case, but let's imagine that some of the allergies in our database have pollen capitalized. What I'd like to do here is make sure that all of my text is flattened to lowercase. So let me show you a little bit of that. We can wrap using either lower or upper the text that we're comparing in a lower or upper operator to take the data in a field, such as the description field, and make all of those characters lowercase or all of those characters uppercase. So what I'd like to do is make sure that allergies.description is all lowercase. Because right now it's mixed case. Allergy has a capital letter, and then to grass pollen is all lowercase. So what I'd like to do is just say lower and wrap that in some parentheses. And what that will do is just say, I'm going to transform the description to all lowercase and then compare that text to this pattern of some characters, lowercase pollen, and some characters, and see if there's anything there. Now, this should not, in our case, actually change our results. I'm going to run that, and we won't actually see any differences. All right. I want to pause here, see if there's any questions about that before giving you your next hands-on coding opportunity. Let me make sure I've got my chat visible. Any other questions? If not, let's practice using like. So you would like to research patients born in the 1970s. So that is any year starting with 197. Any year starting with 197 would work. So use a like statement to enrich the query that's shown and limit the patient set to just those patients that you care about, that you're looking for, who are born in the 1970s. So I'm going to give you a few minutes to try this on your own. When you're done, when you've had a chance to do this, give a thumbs up to that comment in chat, and then we'll complete the query together. Awesome. All right. So I'm going to just run this just to see what it looks like before I filter, just out of curiosity, because maybe I'm not exactly sure how birth date is even coded. It might be helpful for me to see how it's coded here. All right, so it looks like it's year, month, day. So that might be helpful for me in figuring out how I want to do my wildcard. So I'd like to put a where statement in here. And I'll say where patients dot birth date is like, and in this case, I could put potentially a wildcard symbol at the beginning, but I don't have to, because I know that the birth date starts with the year. So I'm just going to say 1970 and then some sort of string after that. And it doesn't matter to me what the year or the month or anything following that is, just sometime in the 1970s. And let's see what that looks like. And there are my patients that were born in the 1970s. Great. Any questions about that coding example, or any errors that people ran into or problems before we move on? All right, let's talk about aggregate functions. All right, aggregate functions can be used to get a single value related to multiple rows of data. And it's really important to remember that aggregate functions return one value and one value only. So this aggregation could be a numerical statistic, like the sum. Give me the sum of the weights of all the crates, because I want to see how heavy all the crates in the plane are, let's say. Or it could be the standard deviation of all these rows. Or it could pull out a special value, like the minimum. What is the minimum age? What's the youngest patient I have? Or the maximum value. And this works for numbers. It can also work for strings because of alphabetical order. What's the what's the max last name, right? It could be Zamboni, right? Something towards the end of the alphabet. And there's other possibilities for aggregate functions as well, such as giving the count of rows or pulling a random value from rows. Give me just a random value from this selection of weights, let's say. So here are some commonly used aggregate functions. Count, it does what it says on the tin. It returns the count of non-null values among the column that's provided as input. Sum, it adds things together. Min and max, again, do what you expect. Average, in this case, it will provide the numerical mean of numerical values from a column. So, and count will ignore null values. And this can help you figure out how many non-null values are in various columns, as we see here. So in our patient database, we have presumably all of our patients were born. Hopefully we have a birth date for all of them. It's possible that some of our patients we didn't collect a date of birth on. That's possible, I suppose. But it is likely that most of our patients are alive. And so maybe we want to understand what are sort of the vital statistics of our patient data set. So I would like to count from the patients table how many total rows I have. So count everything as total rows, and that'll give me one value, right? And it'll label that one value total rows. And then please count the number of non-null birth dates. So look in that birth date column, how many non-null values are there? 4, 10, 200, count how many there are. Give me that value back and call it births. Do the same thing in death date and call that deaths, and give me those values back. So let's run that. And that's what this looks like. So there's 25 rows. We have birth dates for every one of those patients, and we have date of death for 5 of them. So SQL will do its best to use the aggregate functions regardless of what type of data is in the column. But outputs will make the most sense if the data type kind of goes along with the function, right? So sum obviously is going to work best with numbers, right? Sum, if you're summing things, it makes sense that those would be numbers. But there are some aggregate functions that are typically used with numbers that work okay with other types of data. We talked about minimum and maximum, for example. They are typically used with numbers, but they might be useful even working with text data because they can give the first or the last, the min or the max value of the text because it can be ordered alphabetically, right? So here I'm saying, look in the patient's table, give me the sum of patient's expenses, give me the maximum of the patient's last name, the minimum of the patient's first name, and the average of the patient's coverage. And let's look at that. All right. So just another example of aggregate statistics. Now, often what we want to do are gather statistics or aggregate information by group, such as the average BMI for men patients and for women patients, or the standard deviation of reading test scores in teens with condition 1 or condition 2 or condition 3, right? And that's where the group by clause can be used to group results so that you can get statistics for each group. So group by is used in combination with aggregate functions to generate summary statistics about the larger data set that was grouped into various sections using the group by. And this can be very tricky. I would say this is probably where a lot of new SQL users trip up and have the most problems, is group by and aggregation, is where I see a lot of sort of like early headaches. So just like keep your eyes peeled. So let's look at a group by function in action, and see like where it can kind of go amiss. All right, so let's just take a look at this. I'm going to run this. And what this is doing is saying, please group the patients by sex. So however many categories there are in sex, maybe it's male, female, intersex, unknown, missing. I don't know. I don't know how many categories there are, but group them according to that, please. And then for each of those groups, I want you to report back to me the following. Please give me the sex. It should be one and only one value because you grouped them, right, into these distinct values. So there should be just one value for that group, the patient's sex. And then these aggregate values, which should also just be one value, right? So the count of birth dates as births, the count of death dates as deaths. So this should give me one row for each group. And I'm really hammering home the just one value. It's really important. So for males, we have 10 births and 2 deaths. For females, we have 15 births and 3 deaths. All right. So one of the reasons why group by aggregations can be confusing is that you cannot ask for something in your select clause that could give more than one value, right? For example, if I were to add here patient race, and we think about what SQL is doing behind the scenes. It's grouping by sex. So it's got the male group here and the female group here. And it's going to produce one line of output for the male group and one line of output for the female group. It's going to be really easy to give the sex. What's the sex for the male group? Male. What's the sex for the female group? Female. What's the race for the male group? That's going to be impossible to know, right? Because even if it does happen to be the case today that the entire male group is of one racial group, that is not necessarily true, right? There could be more than one race represented. And so in almost every SQL flavor, this is going to give you an error. Now, in the SQL flavor that we use here, a la SQL, it does not give an error. And this is one of my sort of annoyances because I think it should give you an error. Let's see what it does. It's going to give you null. This should give you an error and say you can't ask this question. You asked for something that was neither grouped by nor aggregated. So I can't do this thing that you're asking. This is really important, so I want to pause here and get some reaction emojis. So if that clarification of you need to have one value and one value only, because in group by an aggregation, you're getting one row per group. So everything has to have one value and necessarily only one value. If that makes sense to you, can I get like a smiley face emoji or a heart emoji or a thumbs up emoji? And if that is still a little bit fuzzy, can I get like a thumbs down or like a frowny face, like reaction? I got some positives. All right, perfect. You will make this mistake. I still make this mistake where I ask for something in the select that was neither grouped by nor aggregated. So I want you to hear that phrase, neither grouped by nor aggregated, so that when you see it, you're familiar with it. All right. So I like to sort of, hang out there a little bit. Even though that's going to keep us from probably finishing everything today, it's really important to pause there. Now, what you can do is group by more than one column and say, give me all the unique combinations of sex and race. I'm going to group by sex and race. So please group by all the white males, all the white females, all the black males, all the black females, et cetera, et cetera. Please make all of those groups, right? And let's see what that looks like. And you can see an example of that, right? Excellent. Now, let's take a look at this word, having. This is our last topic for the day, and it's one that that I left for the end because it's one that you'll use relatively less often. It's similar to a where, but they're not interchangeable. Where is for filtering rows and having is for filtering groups. So let's say you want to filter groups. So you want to filter, by zip codes, but you only want to find the zip codes where there's at least 15 patients that have your condition of interest, right? So you want to get rid of all of the groups that have just 1 or 2 patients. That's where having comes into play, all right? So I'm going to leave this line commented out, which means it's not going to be included. So this says, show me the county and how many patients are in that county. All right. So we have the subjects here. We have 7 in Middlesex County. We have 2 in Barnstable. We have 4 in Plymouth. Now, I'm not interested in counties that just have 1. So I'm going to say, you know what? Give me back just those counties where the count is greater than 1. Show me the more populous counties. And that's what that looks like. All right. And we've done a lot, and we're really at the end of the hour. There is one more share and your turn. And I'm going to leave this a little bit as homework. I'm going to have Rose share this link with you. This is a bit of a challenge because I'm not giving you any sort of scaffolding to work with. And, I knew that this was going to be a bit dense, so I'm not going to have a chance to really go over this with you. But if you scroll down, there is a little reveal at the bottom. So you can sort of reveal an answer that works if you so choose. So I want to invite you to work with that later on today or at your leisure when you get a chance. And that sort of combines some of the different things that we worked on today. But what I want to make sure that we go over today are some of these closing slides. So just as a recap, we covered several really important functions represented in SQL by these keywords. So case allows you to classify or give different conditional results depending on a conditional value. So we talked about case statements. We used like for pattern matching, which can be really useful. And we talked about the use of lower and upper in case you're not exactly sure what the capitalization of your data is, and you just want to make sure you're comparing apples to apples. That you can say, I want to make everything lowercase and compare it to a lowercase pattern. Or I want to make everything uppercase and compare it to an uppercase pattern. That makes it a lot easier for you to do that. Aggregate functions can return one value for multiple rows. And these are really powerful when they are combined with group by. And they can be really powerful as well, these group by, when they're used with having, because that way you can filter out just the groups that meet your conditions, that are a certain size or something like that. There's some additional resources here that you might be interested in. Also, there's some upcoming sessions. So if this intermediate session was interesting for you and somebody else in your team might benefit from it, we're going to give that again on December 3rd. We also will be doing SQL joins. That's the final session in this series. 2 dates in December, so please check that out. Those will be useful. And finally, we offer 3 different ARCUS on-ramp workshops. And each of these are focused on a different aspect of doing research in ARCUS. And these are a little bit different from these skill series in that the focus is really on how to work in an ARCUS lab. The great thing is these use real patient data. So you can actually get your hands on some real data and work sort of understanding how research really does get done in an ARCUS lab on real patient data. That means you have to have completed city training, attest to the ARCUS terms of use. There's a little homework you have to do. So you do have to sign up ahead of time. It's a little bit more hoops to jump through, but I think it's worth doing. So consider that. And I do have one last poll for you in these last couple of minutes. Please do take that. There's 2 questions in that. I'm going to turn off the recording to allow you to just go ahead and answer that last poll, which sort of helps us understand how we can make better use of your time, which is a really valuable resource that we do not want to take for granted.